Hey crew, just a quick video to see if you're getting your constraints put on correctly for the marble climber here. Just double check. It's the one issue we run into usually is with the cams on the bottom driving the pistons, and how the crank and the crank at the end here runs this cam, or the end retainer cam, to the long dowel and then to the piston cams. So what we really need to do here is get a bunch of work planes put on to make sure we're just driving everything correctly. I'm sure there's some other ways to do it with joints now, but back when I built this originally, joints were a new thing, and I knew how to use constraints, and I know it works, so that's what we're just sticking with on this one anyway. The big thing, like I was saying, is the work planes. And all of these cams or end caps here, when we go into them, that very first sketch when you drew all these things, hopefully you were using your origin point, because then you can easily use those work planes to turn on, and you know that they're perfectly through the center and aligned with your holes and with the center of your cams. Let me just return back out. Turn them on in your origins if you need to make them match mine. And same thing with like the long dowel. You turn that one, you go back to its original sketch. Make sure that that original sketch is on an origin point, so then you can easily turn on origin work planes, and everything's nice and centered for you automatically. And what we do then is we just mate these two work planes together, either with the mate or flush constraint out here at this point. And those two flat surfaces, so to speak, the planes, they're going to be connected and then stick together as you rotate this. Notice the handle does not need this. It's okay if the handle rotates within the hole. That'll be okay. Moving on here, the piston cam. Go into that. Go into the sketch that made it. Again, make sure everything is on the origin point and the other hole offset is on a work axis, or essentially work plane. That way we can just easily turn on that origin plane to be through the center of the cam and the center of the hole. Turn back. And then what we're going to do is mate that work plane to the work plane in the long dowel. And again, what you're going to do with the piston cams is you're going to mate one and then flush the next, mate the third, flush the fourth, mate. So just opposites, and that'll just give you that 180 effect as you go across. And then I use a tangent constraint between the cam and the bottom of the piston. So I highlight that. There's my cam. I look down through the list. Work plane, sorry, just looking at I mated the hole to the long dowel, obviously, and at that moment it still rotated around until I mated the two work planes together. The flush, that's just to center the cam under the piston, and to do that, quick note was I put a work plane in the middle of the cam, work plane in the middle of the piston, and then I could just flush or mate those together easily. And then the last one right there, it is tangent. So each cam should be tangent to the bottom of a piston, and that'll keep that connection solid as they rotate around, or sorry, I should say keep the two items connected as the cam is rotated around. And if these are all in there, that should help when you go to the dynamic simulation to make sure that all of these items that are rotating are in a welded group, a mobile welded group. Sorry, let me rephrase. So let me double check that. Go to environments, dynamic simulation, and there we go. You're gonna have two welded groups in here. One is just basically the structure, the framework, but the other welded group is it's a set of items that are all joined together but still can move, right? Because they're mobile together, right? They have motion as one. There we go. Yeah, the pistons are all goofy because gravity's not turned on at the moment. But that group, it's important that the dowel, crank cam, retainer cam at the backside, the crank dowel, or crank handle, and then the piston cams, these are all in one welded group. Okay. And then, of course, you have to put in your other joints and stuff, as that other video all shows. Standard joints, the force joints, going through, and everything the marble contacts, you have to click and do a pair of 3D contacts between and get those all set up like that other video showed. But anyway, those constraints leading up to this, if I finish, all these constraints on how these cams are connected to the dowel and relate to the piston. That's just important to get them in that mobile group together. Hopefully that helps. Good luck, and let me know if you have any more questions.